Hello, and welcome to a little video about solving exponential equations with common bases. Let's do it. Okay, so the first one we have here is 4 to the power of 2x minus 2 equals 32 to the power of x. Now, I can't think of any power that 4 can be raised to get 32. So let's think about how can we rewrite 4? Well, 4 can be rewritten as 2 squared. Alright, well, can 32 be rewritten as 2 to the something power? Because we do want to have a common base. And in fact, yes, 32 is 2 to the 5th. Okay, let's get rid of these parentheses by distributing. Well, this is the power rule. When you raise an exponent to an exponent, we multiply them, so not really the distributive property. All right, so this is what we get. 2 to the power of 4x minus 4 equals 2 to the power of 5x. Now, something incredibly beautiful happens when we have common bases. We can forget completely about them. Because our problem really lies in the exponents. Okay, so the 2's are gone. I don't need to think about them anymore. Alright, so let's start this problem, solving for x, by getting the x's to the same side. So I'm subtracting 4x. So I have negative 4 equals x. There we go. Let's try another one. Okay, here we have 9 to the power of 4 equals 81 to the power of x minus 9. Now, I do recognize that 81 can be written as 9 squared. So the left-hand side, I'm not going to rewrite because I already have a base 9. But 81 becomes 9 squared. All right, so we have 9 to the 4th equals 9 to the power of 2x minus 4. Since they have a common base, I say, farewell 9, I'll see you later. And I'm just focusing on those exponents. Let's solve this equation by first adding 4 to both sides to get our constants on the same side, and then I'll divide by 2 to get my variable on its own. X equals 4. Okay, beautiful. Let's continue. The next one I want to do is a funky one. I make sure to give this to my students every year because it is such a weird problem, but when you see how it's done. Okay, so I see a base of 2 and a base of 4, and I automatically know that 4 is 2 squared. I hope that that is something that you can intuitively see as well. All right, so we have 2 to the 3x equals 2 squared to the power of 2x, because that's what 4 is. So we actually have 2 to the power of 3x equals 2 to the power of 4x. Since we have common bases, I say farewell bases, and I have 3x equals 4x. Now what do we do here? Don't worry, I know it looks weird. What we're going to do is we're going to get the x's on the same side. So I'm going to subtract 3x from both sides. I know, there's only 3x on the left-hand side. Well, 3x minus 3x still gives us an answer. It's 0. X equals 0. Okay, so that was a weird one. Let's continue. Ooh, okay. Here we have 625 as a base and 25. 625 is actually 25 squared. Right, let's multiply those exponents. So I have 25 to the power of 6x plus 2 equals 25 to the 3x minus 1. I have the same base. So farewell 25. Let's deal with your exponents. Okay. I'm going to move over the 3x by subtracting it from both sides. And simultaneously, I'm going to subtract 2 from both sides. Check it out. My 3x's cancel here, and my 2's cancel there. 6x minus 3x is 3x's. Negative 1 minus 2 is negative 3. And we finish by dividing. And x equals negative 1. Right, the next few problems are going to be funky because they have weird and big numbers that you may not be that familiar with. And the reason I'd like to do it is because on the assignment, if you're one of my students, on the Delta Math, they use these problems. So I took them straight from Delta Math. And I wanted to make sure you saw them, so at least you have these in your notes so you can go back to it when you're working on your work. Okay, 10, 24, and 64. Their common base is going to be 4. It's going to be 4 to the power of 5 over here, and 4 to the power of 3 over there. Let's multiply our exponents. We have a common base now. So, farewell, 4. And we have 15x equals 3x plus 12. Let's get those x's on the same side by subtracting. So we have 12x equals 12. How beautiful. Let's just divide both sides by 12. X equals 1. Okay, let's do one more with some crazy numbers. Again, I want to make sure you see this so that you know what to do when you get to your Delta Math. All right, we have 7,776 and 216. Their common base is actually 6. 776 is x to the power of 5, is 6 to the power of 5, and 216 is 6 to the power of 3. Let's multiply our exponents. And because we have the common bases now, we can say farewell, common bases. We'll deal with you later. 5x plus 5 equals 3x minus 15. All right, let's move the variables over and the constants over. I'm going to subtract 3x from both sides, and also I'm going to subtract 5 from both sides. That way these 5's cancel, and then these x's cancel. Right, 5x's minus 3x's leaves us with 2x's. Negative 15 minus 5 is negative 20. Let's divide by 2 to get x by itself. X equals negative 10. And that, my friends, is that. All right, I hope this was helpful. If you have any questions, please feel free to reach out to me or to your teachers. We'd love to help you understand this better. Well, have a wonderful rest of whatever day it is for you. Bye.